All right, this is the third round of review. I've mixed up both free response questions and multiple choice. I am going to try to show my work uh, in the same space, so I'm sorry if this is a little bit all over the place, but that'll be easier, I think, than switching back and forth. Okay, a particle moves along the x-axis so that its velocity at any time greater than 0 is given by this function. The position is 5 for t equals 2. So 2. So actually, I would like to I like to make a note of myself if they don't completely come out and say it in this format. That means x of 2 equals 5. Write a polynomial expression for the position of the particle at any time t greater than or equal to 0. So for part A, I crunched this in here in my answer key, but I think I'm going to come up here. Okay, so x of t is equal to the integral of v of t dt. So start there. So I need to integrate 3t squared minus 2t minus 1. And that comes out to 3t cubed over 3, so t cubed, minus 2t squared over 2, minus t squared, minus t plus c. This is why we were given this position. I can set this equation equal to 5 when I plug 2 in for t and solve for c. This is 4 minus 2 is 2. Subtract 2 over here, so it looks like c is 3. So the position function is x of t equals t to the third minus t to the second minus t plus 3. And that's for t greater than or equal to 0. I don't think you have to write that, but that's what they asked me to do. For what values of t between 0 and 3 is the particle's instantaneous velocity the same as its average velocity? Let's assume this is no calculator. I don't really know if it is or not. So we need to set the instantaneous velocity, which is v of t, equal to the average velocity. So how about we find the average velocity, or the AROC, average rate of change, first? So the average velocity is the change in position over change in time. That's x of 3 minus x of 0 over 3 minus 0. All right, so x of 3 is, where did x go? Here we go. That's 8 minus, 3, sorry, 27 minus 9 minus 3 plus 3, that's x of 3, minus x of 0, that's just 3, all over 3. Okay, so minus 3 plus 3, 27 minus 12 is 15 over 3. So AROC is 5. All right, and then I'm coming back over here. Again, sorry for the messiness here. And then I need to set v of t equal to 5. So when is 3t squared minus 2t minus 1 equal to 5? This is a quadratic, so you need to get it equal to 0 to solve. And does this factor? I don't think any combination of 3 and 1, 3 and 2, or 6 and 1, I don't think that's going to give me 2. I'm just going to go to quadratic formula. So positive 2 plus or minus the square root of 4 minus, that's 2 squared, so 4 minus 4 times 3 times negative 6, all over 2 times 3. 2 plus or minus the square root of, so this is 4 plus, what is 12 times 6? 72. 4 plus 72. Is that right? 12 times 6? Yeah, okay. So that's 76 all over 6. We're not required to simplify this, but I bet it does simplify. Can I take a 4 out of this? Let's see. This is 4 times, 4 goes into 7 once, 36. 4 goes into 36 9 times. Yeah, so now here's the thing. My answer is not plus or minus. My answer is I'm gonna divide by 2 here. 1 plus, this was a 2, so 1 radical 19 all over 3. It's not minus because we're only on the interval 0 to 3. So this is the time at which the average velocity is the same as the instantaneous. And then part C, find the total distance traveled by the particle from the time 0 to 3. Total distance, remember, is putting an absolute value around your velocity. If you're allowed to use a calculator, it's easy. You just throw an absolute value around this. But because I'm not allowed to use a calculator, I need to see when does the velocity dip into the negatives, because I need to make sure that I force that area to be positive. So let's go ahead and factor the velocity equation. It's set equal to 0. So t equals negative 1/3 and t equals 1. This is a positive quadratic, so the velocity is negative between here, and we're looking from 0 to 3. So 0 to 3. So it's negative and then positive. So when I set this up, it's going to be the integral from 0 to 1. That needs to get a negative sign in front because this area is going to be negative, so I'm forcing it to be positive. A negative is a positive, of v of t dt, plus the integral from 1 to 3 of v of t dt. All right, and we already integrated back here, right, without our plus c because we're doing a definite integral. So I'm going to come down into the space because I don't think I need it. So negative, this is t cubed minus t squared minus t, evaluating from 0 to 1. Add to that the same antiderivative, but you're going from 1 to 3. All right, so plug 1 in, you get 1 minus 1, which is 0, minus 1. Minus, plug in 0, you get 0. Add to that plugging 3 in. When we plug in 3, we get 27 minus 9 minus 3. Subtract what you get when you plug 1 in. 1 minus 1 is 0, minus 1. This is positive 1. This is 27 minus 12, which is 15 plus 1. So this is 16. So I'm getting 17 as the total distance. All right. Number 2, again, sorry for all the mess. I guess probably using a separate sheet of paper would be best. It's just hard to make an efficient video to go back and forth here. This is no graphing calculator allowed, and we're given a graph of f prime. This is a pretty classic problem, always on the AB exam, always on the BC exam. AB and BC, they share 3 free response questions. So there's a pretty high chance you're going to have something like this on our semester exam as well. Here's a graph of f prime. It's defined from negative 3 to 4. F of 0 equals 3. The graph of f prime is the derivative of f. It consists of one line segment and a semicircle. On what intervals, if any, is f increasing? Justify your answer. F is increasing when, I like to justify first most of the time, when f prime is greater than 0. So this is on, where is f prime greater than 0? On including negative 3 to negative 2, because at negative 3 we're definitely greater than 0 here. And anywhere else? No, it's equal to 0 at 2, but that's it. All right, and let's see. Part B. Find the x-coordinate of each point of inflection on the graph in the open interval negative 3 to 4. Justify your answer. So F has a POI when F double prime is positive. I don't have F double prime information, though I have F prime information. So how does F double prime being positive relate to F prime? So F double prime is positive, which is also when F prime is increasing, right? Because f double prime is the derivative of f prime. So if something's derivative is positive, that thing is increasing. So now I just need to give the intervals where f prime is increasing. So f prime is increasing from x equals 0 to 2, and that's it. Find an equation for the line tangent to the graph at the point 0, 3. So I need a point, which I have. I need a tangent, so I need f prime of 0. F prime of 0 from the graph is negative 2. So to write my equation, it's y minus 3 equals negative 2 times x minus 0, or you could just say x there. And finally, find f of negative 3 and f of 4. Show the work that leads to your answers. We have f of 0. We need to find two other points. One is to the left of 0 and one is to the right. I always like to set up the fundamental theorem of calculus in order. So I don't go based off of isolating the unknown. I just go in order. So if I want to find f of negative 3, I'm going to start at f of negative 3. I'm going to add the integral from negative 3 to 0, because that's the point I have, of f prime of x dx, and that will be equal to f of 0. And then I can sub in stuff that I know. So f of negative 3, I'm not even going to subtract this yet because I don't want to get signs messed up. So I'm just going to find this area first. So what is the area from negative 3 to 0? So that's this area here plus this area here. It should be something net negative, right? So this area is 1/2 times 1 times the height 1. So this area is positive 1/2. This area is negative 1/2 times the base is 2. The height is 2. So that area is negative 2. So this is f of, let me write this over here. So this is f of negative 3 minus 1/2 minus 2 is minus 1/2. So minus 3 over 2 equals f of 0, which I know is 3. That means that f of negative 3 is equal to 3 plus 3 over 2. That's 4.5. Or 9 over 2. It doesn't matter in which form you write that. I'm also supposed to find f of 4. So I'm going to start over again. Comparing f of 4 to f of 0. F of 0 is on the left. So you would do f of 0 plus the integral from 0 to 4 of f prime of x dx. That would equal f of 4. F of 0 is 3 plus, let's take a look at this area now. So now we have the area. Now this one's a little trickier here. We're looking at this area and this area. Definitely negative, right? How do I find that area? Remember, this is a semicircle, and I could connect the bottom of this to form this large rectangle. This is basically a leftover area. This is saying find the area of that big rectangle, subtract the area of the half circle, and you should be left with the net area, right? So what's the area of the rectangle? Well, it's negative, remember. It's negative 4 times 2, so it's negative 8. And we're subtracting this negative area as well. Half circle is 1/2 pi r squared. The radius of the circle is 2, right? We go from 0 to 2 to get out here. So 2 squared. So half of 4 pi is negative 2 pi. So this is actually, and again, remember, we're subtracting the areas. So negative 8 minus negative 2 pi is negative 8 plus 2 pi. All right, so let me find my spot. So this area was negative 8 plus 2 pi. And that is still, I was kind of doing some math in my head, like, okay, wait, so 2 times 3.14 is 6 point something. So yeah, that'll still be a negative overall area, just making sure my signs weren't messed up. And that's equal to f of 4. Simplify that if you want, or don't. You could just leave it like that, or you could say, okay, that's 2 pi minus 5. It kind of bothers me not to simplify it. But yeah, you're not required to simplify on a free response. All right, look at number 3 here. We have a differential equation, dy dx equals this. Find a solution for y equals f of x to the differential equation satisfying f of 0 equals 1/2. this goes back to chapter 6. We are finding, we're doing separate, integrate, celebrate. So I need to separate, first of all. It's going to be e to the 2y times dy equals 3x squared dx. And then I can integrate that. The left side needs a little bit of u sub. U is 2y. Du dy is equal to 2. So du over 2 equals dy. That means that when I replace dy with du, it's going to have an over 2, or like 1/2 out here. All right, so 1/2 times e to the integral of e to the u is e to the u equals 3x cubed over 3, so x cubed plus c. And I want to plug in the point that I know right now. So y is 1/2 when x is 0. So 1/2 e to the 2 times 1/2, e to the first, is equal to 0 plus c. So there's c. So now it's 1/2 e to the 2y equals x cubed plus 1/2 e. Let's get the 1/2 out of there. E to the 2y equals 2x cubed plus e. How do I get the y out of the exponent? I natural log both sides. So now it's 2y equals the natural log of x cubed plus e. Remember, you can't simplify this at all. The natural log of 2x cubed, plus e. You can't simplify this and make natural log of e1 or anything because it's addition. There's no way to expand that or simplify. Finally, divide the whole thing by 2. So that's our function for y. All right, and part B, find the domain and range of function f found in this part. Okay, so domain for a log function is that the expression inside of the log needs to remain greater than 0. Remember, you can't log or natural log 0 because you can't raise a number to an exponent and get it to equal 0, a non-zero number, I should say, and you can't raise a positive base to an exponent and make it negative. So for that reason, I'm setting 2x cubed plus e greater than 0. X cubed is greater than negative e over 2. And so x would be greater than the cube root of negative e over 2. Excuse me. So that is our... And I'm trying to decide if I need a number line for that. No, because there's only the 1 0. So yeah, it is just going to be anything greater than that. If I had multiple zeros here, if this factored and I had multiple zeros, then I would need a number line to see where it's coming out positive and negative. But anyway, that's the domain. And then what about the range? Remember, natural log functions, even if they're kind of complicated like this, natural log functions have a range of all real numbers. We could graph this to verify, but no matter what you plug in, if you get the natural log of some small fraction in here, you're going to get something really negative. If you get close to its asymptote, close to this asymptote, you'll get something negative. And as you put in larger and larger x values, the function will just continue to grow. So it's all real numbers for the range. All right, number 3. Let f be a function with f of 1 equals 4, such that all points x, y on the graph of f, the slope is given by this. So this is the dy dx equation. Find the slope of the graph at the point where x equals 1. So remember, when x equals 1, y equals 4. So dy dx evaluated at 1, 4 is equal to 3 times 1 squared plus 1 over 2 times 4. 3 plus 1 is 4. 4 over 8 is 1/2. All right. For the next part, it says write an equation for the line tangent to the graph of f at x equals 1 and use it to approximate f of 1.2. Okay, so if I do that, let's see. Yeah, if I do that, I first want to get my point slope equation. So I have the point and I have the slope. So for part B, It's going to be y minus 4 equals 1/2 x minus 1. And f of 1.2 is approximately 1/2 times 1.2 minus 1. And then you'd have to add 4 to it. This is just 0.2, and half of that is 0.1 plus 4, so 4.1. I think my answer key might have been wrong on that. Yeah, because I had the wrong slope from the first part. Sorry. Anyway, okay, part C. I'll fix that when I post it. Find f of x by solving the separable differential equation, this, with the initial condition, this. So separate, integrate, celebrate. So 2y. Actually, let me put my work over here. Let's see. Let me start up here. 2y times dy equals 3x squared plus 1 times dx. Integrate. No u sub here. This becomes 2y squared over 2, so y squared. This becomes 3x cubed over 3, x cubed, plus x plus c. Use the condition 1, 4. So 4 squared is 16. That equals 1 plus 1 plus c. So c is 14. So y squared equals x cubed plus x plus 14. Y equals, is it plus or minus the square root of all of this? Well, when I plug in 1, I'm supposed to get positive 4, so it's just the positive square root of x cubed plus x plus 14. Use your solution to find f of 1.2. I'm treating this as a non-calculator problem, so I'm not going to simplify this. I'm just going to say it's 1.2 cubed plus 1.2 plus 14. And I'm just going to leave it like that. Even if we could do the math. We can change this to a fraction and do all the math, but that just seems unnecessary. Okay. Now we have a multiple choice problem. So which of the following are antiderivatives of this? Now, the quickest way to do this is not to do all these different integration methods. It's just to go ahead and say, well, if these are all antiderivatives, it means I should be able to take the derivatives of them and get this. So let's take the derivatives of each of these. See what happens. This cubed means natural log of x cubed over 3. So that derivative would be 3 natural log of x squared over 3. Remember, you have to chain rule. What's the derivative of natural log x? 1 over x. So am I getting ln squared? Yes, ln squared of x over x. So 1 works. That crosses out that option and that option. Does 2 work? The only difference between 1 and 2 is there's a constant. The constant's going to become 0, so 2 has to work as well. So that's out and that's out. So it has to be C. We can double check number 3 if we want to. But I don't really want to. If I needed to do this instead of quotient rule, I would divide each one and take the derivative of each part. I'm not checking that. It's C. Okay, number 5. If you had extra time, you could go back and double check or something. All right, number 5. The function f, whose graph consists of 2 line segments, is shown to the right. Which of the following are true for f on the open interval a to b? All right, so here's f. The domain of the derivative of f is in the open interval a to b. The domain of the derivative of f is the open interval a to b. So does f prime exist for every value a to b? No. F prime equals undefined at x equals c. There's a sharp turn here. So there's no f prime right there. The f prime graph looks something like this. It's got a positive slope until I hit c, and then it jumps down to a negative slope, right? So no for 1. That knocks that out and that out. F is continuous on the open interval a to b. F is continuous. Yes, this graph has no holes or asymptotes. So 2 is correct. That knocks this one out. The derivative of f is positive on the open interval a to c. Derivative is definitely positive. That's a positive slope on a to c. So I believe 2 and 3 are the solutions here. All right, number 6. If f is continuous for all x, which of the following integrals necessarily have the same value? So we don't have any numbers to go off of, so we have to be kind of careful here. Let's do like a sketch. F of x can be anything. But this first one is saying, let's just say A is here and B is here and F is this. This is the area I'm working with. What's happening to this one? So B subtracted A and this subtracted A, and F was plus A. That means left A units. So if we go left A units, and see, so my A is kind of in a weird spot. Let me do this. If going left A, put this at 0, that should be the same area, right? We're just shifting all the bounds over. A units, it should be the same area. So 1 and 2 should be the same. I think that's right. And if that's right, I can't imagine why the other ones would be right. Let's just see what this one's saying. This time you're adding C to the two values, so you're moving the bounds to the right. But this is a shift to the left, C units. So that doesn't work because you're shifting the graph C units to the left. So now it's like over here. But you shifted the bounds of integration to the right. So that doesn't work. That's not the same area. So 3 can't be involved. So it is just 1 and 2. An equation of the line tangent to this graph at its point of inflection is what? So we need to figure out the point of inflection and then come up with the tangent line. So y prime is equal to 3x squared plus 6x. Y double prime is equal to 6x plus 6. Y double prime is equal to 0 when x equals -1. And y double prime definitely changes signs. So that is a point of inflection. Now, the question is not what's the point of inflection, it's what's the equation of the tangent line at this point. So y of -1 for my point is -1 plus 3 plus 2. 2 plus 2 is 4. And the slope is y prime of -1. Y prime's up here. That's 3 minus 6. Y minus 4 equals -3 times x plus 1. All of these are in y equals format, so I need to do a little work here. So do we have a -3x plus 1 option? Yes. Option B. If the position of a particle on the x-axis at time t is this, then the average velocity of the particle on 0 to 3 is, so we have position, average velocity, a rock, is s of 3 minus s of 0 over 3 minus 0. S of 3 is -5 times 9, so -45 minus 0 over 3 is -15. Not bad. The derivative of this integral, if we're taking the derivative of an integral, that cancels out. The variable that was in here goes in here. We technically multiply by the derivative of the variable, but that's just 1. So it should just be square root of 1 plus x squared. Right there. If this were 2x, it would be the square root of 1 plus quantity 2x squared times 2, because you'd have to multiply by the derivative of 2x. Okay, this one, we have another free response question here. Oil is leaking from a pipeline on the surface of a lake and forms an oil slick whose volume increases at a constant rate of this. So I know dV dt is positive 2,000 cubic centimeters per minute. The oil slick takes the form of a right circular cylinder with both its radius and height changing over time, and they give us that formula. Part A, at the instant when the radius of the oil slick is 100 centimeters and h is 0.5 centimeters, the radius is increasing at a rate of 2.5 centimeters per minute. dr dt at this time, I'm not going to write that down, is 2.5 centimeters per minute. At this instant, what is the rate of change of the height of the oil slick with respect to time in centimeters per minute? So for part A, I'm going to put this down here. For part A, we're using the volume formula, but we need to take the derivative with respect to time of both sides of this equation. And there's no subbing out a variable for anything because both R and H are changing and they don't have a proportional relationship like they would in a cone. So this is dV dt. I need to do product rule here. So I'm going to treat pi r squared as the first function and H is the second. So first times derivative of the second plus second times derivative of the first. That'd be 2 pi r dr dt. Now you can sub in numbers that you know. dV dt is 2,000. Pi times r is 100. 100 squared. We don't know dH dt. Plus h is 1/2 times 2 pi times 100, 200 pi, times 2.5, 5 over 2. All right, this is 100 pi. Actually 50 pi times 5 is 250 pi. So this is 2,000 minus 5 times 50 is 250 pi divided by 100 squared. So that's 4 zeros. 10,000 pi equals dH dt. I bet this is calculator, but I'm just going to leave it like that. Part B, a recovery device arrives on the scene and begins removing oil. The rate at which oil is removed is 400 t cubic centimeters per minute. This will be a subtracted volume, by the way, if we're compiling things. T is time in minutes since the device began working. Oil continues to leak at this rate. Find the time when the oil slick reaches its max volume. Justify your answer. If I want the maximum of something, I want to take its derivative and find critical numbers. So the overall volume is the amount leaking in minus the amount leaving, right? And the rate at which the overall volume at dV dt, let's call it like, how about instead of dV, let's call it like dA for amount or something, is equal to the amount coming in, 2,000, minus the amount coming out. I'm saying that wrong, sorry. The rate at which the amount is changing, this is like the rate of amount of oil left. How about net amount? We just say that. Net amount of oil. Rate of net amount of oil, rate of change of. Okay, this is the rate of change of the amount of the oil slick that's sitting there, basically. It's changing at a rate of 2,000 coming in minus 400 radical T leaving. Yeah, okay. We need to figure out when that's equal to 0. And then we need to see about the sign change. I think this is a calculator problem, so I am going to let Desmos do this for me. Okay, so I've got this function, 2,000 minus 400 square root of t, and I want to know, let's say like that's y equals or something, and I want to know when that's equal to 0. There it is. T equals 25. Gosh, maybe it wasn't a calculator problem. Okay, so that happens at T equals 25. I also can see on this graph that remember, this equation represents dA dt. The amount of oil that's sitting there is positive and then negative. So your dA dt goes from positive to negative at 25. That means that the amount sitting there is increasing then decreasing. So the maximum amount, does it want me to find the maximum amount? Find the time when the oil slick. So the max volume occurs at T equals 25 minutes, which is the relative max. Part C. By the time the recovery device began removing, 60,000 cubic centimeters of oil had already leaked. Write but do not evaluate an expression involving an integral that gives the volume of the oil at this time. Okay, so we kind of started this on part B. This is going to be really little. So we've got 60,000 sitting here. And we're going to add to that the amount that is still leaking in. So from time 0 to time t, we've got 2,000. This rate of 2,000 is still leaking in. And that would just be like D. My pen stopped working. Sorry. At the time. Sorry, not 0 to t. At the time that we reach this max. 0 to 25 of 2,000 dt. And then that we are subtracting out from 0 to 25 r of t dt. So 400 radical t dt. So we've got 60,000 coming in. We're adding to that the amount that's leaking in minus the amount that's being removed. And we don't have to evaluate that. We just leave it as it is. All right. Let's see. This is our last page, and we're back to multiple choice problems. Calculator is allowed, so we'll keep that in mind. The region in the first quadrant enclosed by the y-axis and these graphs is rotated about the x-axis. Find the volume. So, all right, so we're looking at cosine x and y equals x. Let's go ahead and graph that. I want to make sure I'm in radian mode. Yes. All right, so y equals cosine x, y equals x. We're in the first quadrant here, and we're enclosed by those two and the y-axis. So we're looking at this area here. Even though I'm using the graphing calculator, it is a good idea to sketch what you're talking about. So I've got the line y equals x. I've got this y-axis and like a bit of the curve here. And we're not going to round this. It's 0.73909. And we're revolving around the x-axis. So that's going to form something like this. Reflect here. So your big R, capital R, is top minus bottom. So what is that on top? That's cosine x. What's the bottom? 0. Little r connects this inner part back to they both always connect back to the axis of revolution. That is just x minus 0. And the setup for what I'm going to type in here for volume is pi times the integral from 0 to 0.73909 of r squared minus r squared dx. So let's carefully type that in. Pi times the integral from 0 to 0.73909 of cosine x squared minus x squared dx. 1.520 looks like C to me. All right. If f of x equals this, then f prime equals, you need quotient rule, low d high minus high d low all over low low. This has been simplified a bit. So this is 4x e to the 2x minus 2 e to the 2x over 4x squared. A 2 can be factored out of the top. Well, more than a 2, but whatever. That means that 2 can be taken out, and that becomes a 2. Okay, fine. We'll take an e to the 2x out. That gives me 2x minus 1 over 2x squared. That looks like option E. Be careful of the order. See how B is just the same thing but opposite subtraction. So the order does matter there. Okay, for number 13, the graph of this function changes concavity at, so all right, we can't just graph this. I don't think we can just graph this and find that point of inflection. So I think we need to find y prime. Y prime is 3x squared plus 12x plus 7 plus 2 sine x. And y double prime is equal to 6x plus 12 plus 0 plus 2 cosine x. We need to look at we need to graph y double prime and see if it changes signs at any of these points. So let's graph y double prime. We're not going to type in y double prime, just like y equals 6x plus 12 plus 2 cosine x. And take a look at your options for answers between negative 2.33 and negative. So we should be over here. And is negative 1.89. Negative 1.89 is an option. So this is D. All right. What is the next one? We have, let f be a function given by this. For what value of x is the slope of the tangent line to the graph equal to 3? So find f prime and set it equal to 3. So the derivative of 2e to the u is 2e to the u times u prime. The derivative of 4x squared is 8x. I want to set this equal to 3 and solve. And the beauty of solving by graphing is that, or solving with Desmos, is that it's usually pretty easy to solve by graphing. So let's do 2e to the 4x squared times 8x. We want that graph, and we want to graph y equals 3. And we want to see where these intersect. And it is 0.168. Let's see if that's an option. It's option A. All right, number 15. A railroad track and a road cross at right angles. An observer stands on the road 70 meters south of the crossing. Just get this picture going. Someone is 70 meters south of the crossing, and they watch an eastbound train traveling at 60 meters per second. Let's call this A. dA dt is 60, positive, because it's increasing from the origin there. Meters per second. At how many meters per second is the train moving away from the observer 4 seconds after it passes through the intersection? There's this eastbound train here. 4 seconds have passed. So let's say the intersection is 0, 0. Let's see. So the intersection is 0, 0. How this distance here at t equals 4 would be 240, right? And we'll call this observer B, and we'll call this distance C that we don't know. At how many meters per second is the train moving away from the observer? So the distance between the train and the observer is c. So this is asking for dc dt. I know that's a little bit confusing, but yeah, that is our unknown here. The observer is just standing here. They don't have a rate, but what is that? Okay, so our equation is 70 squared plus a squared equals c squared. And if we take the derivative with respect to time, the 70 goes away. That's fixed. But we get 2a dA dt equals 2c dc dt. And we can divide out the 2's. A is 70, and it's not negative or anything because, right? Yeah, because we're just talking about a triangle in general. So 70 times 60 equals C. I guess we could figure out C. I probably need to know this, right? 7, 24, 25. That's a right triangle, isn't it? So this is 250. If you're not sure, you could check your math. I'm like mostly sure. And dc dt is going to be as a decimal, whatever this comes out to. 70 times 60 divided by 250. 16.8. Oh, and that's not the final question, is it? At how many meters per second? Wait, how did I get 16.8? What did I do wrong here? Let's see. Oh, wait, it wasn't 70, or it wasn't, A wasn't 70. My mistake. A was right here, 240. Let's try that. I accidentally put in the observer distance. There we go. 57.6. That was an answer somewhere, right? Yeah, that was our first answer. Okay. Maybe you were yelling at the screen as I made that mistake. Okay, 16. If y equals 2x minus 8, what is the minimum value of the product xy? Y equals this. Product equals xy. If I want a minimum product, I'm going to take p prime. That would be x times dy dx plus y times 1. And, or actually, I could probably, wait, what am I saying? That's silly. Product equals xy. Product equals x times, how about this, 2x minus 8. That's 2x squared minus 8x. What's p prime now? 4x minus 8. That equals 0 at x equals 2. What does y equal? So, and is that a minimum? Let's see. Yeah, p prime would be negative and then positive. So that is a minimum when x equals 2. When x equals 2, y equals negative 4. So the minimum product is 2 times negative 4, negative 8. Honestly, that's also just like a pre-calculus or algebra 2 problem. Find the vertex of that parabola. All right, what is the area of the region in the first quadrant enclosed by these graphs and the y-axis? Wait, didn't we just had that one, but we found volume. All right, so let's graph those again. Actually, I don't need to graph them. I have back here where they intersect. Who is this, right? Cosine x, y equals x, and the y-axis. Yeah, so top minus bottom. So I just need to do a different integral. So this is going to be the integral from 0 to 0.73909 of cosine x minus x dx. And that answer is 0.400, which is option C. Okay, number 18, the base of a solid S is the region enclosed by this graph, the line x equals e and the x-axis. If the cross sections are perpendicular to the x-axis and they're squares, find the volume. So let's go ahead and graph this first. So we want to graph y equals, get that to show up here, y equals the square root of ln x equals e, and the x-axis, which is y equals 0, if you really need to see that. Okay, so we're talking about this region, and we're filling this region with squares, and the squares are perpendicular to the x-axis. So the side of a square, first of all, the area of a square is side squared. The side that we're talking about is going to be square root of ln x minus 0. And we're filling that from 0 to e. So this volume should be the, remember there's no pi or we're not rotating anything, so it's the integral from 0 to e of the square root of ln x squared, so just ln x dx. Oh, and the answer, oh no, there are decimal versions of the answer. Okay, so integral from 0 to e of ln x dx is 0. What did I do? Let's see. Side squared. This is the square root of ln x. Oh, wait, not from 0. From 1. Ah, there we go. We get 1. Is 1 an option? Yeah. So let's scratch that out and make that a 1. All right. Let's see. If the derivative of f is given by this, at which of the following values of x does f have a relative maximum value? It would have a relative max when f prime changes from plus to minus. So let's just graph f prime and see where that happens. Notice I'm not putting in like f prime equals. I probably could, but I don't want to mess with that. Where does it change from positive? Where does f prime change from positive to negative? Right there. And nowhere else. Negative to positive, negative to positive. So it's only right there. 0.91. That is option C. Last question. A table of values for a continuous function f are shown below. If 4 equal subintervals of 0 to 2 are used, which of the following is the trapezoidal approximation? So first let's get the delta x. 2 minus 0 over 4 is 1/2. So we're making little trapezoids out of these, right? So remember the area of a trapezoid is 1/2 times the height times the sum of the bases. The height is the delta x. And the sum of the bases will depend on which two you're going between. So it's going to be these two, and then these two, and then these two, and then these two. So it's going to be 1/4 times 3 plus, we're going to use this twice, plus use this twice. This one gets used twice. This one gets used once. The ends only get used once. The middles get used twice because they get used in two trapezoids. So let's just see what that comes out to. One-fourth times 3 plus 6 plus 10 plus 16 plus 13. 12. All right. I hope that this practice helped. I have office hours, or I'm also available after some of the other exams. We are the last day of the exam this year. So, yeah, come see me if you have questions.